Explaining herbicide resistance. Herbicides work by disrupting a particular plant process or function. Once a weed population is exposed to a herbicide to which one or more plants are naturally resistant, the herbicide kills susceptible individuals, but allows resistant individuals to survive and reproduce. This can occur as a result of target site resistance or enhanced metabolism. Target site resistance. A herbicide has a particular target site of action. If the shape of this target site is somewhat altered, the herbicide no longer binds to the site of action and is unable to exert its phytotoxic effect. There are two major groups of chemistry for the control of grass weeds, which disrupt two different enzymes within the plant: ALS inhibitors and ACCase inhibitors. The acetolactate synthase, or ALS enzyme, catalyses the first step in the synthesis of the branched chain amino acids. ALS inhibiting herbicides, such as sulfonylureas, slowly starve affected plants of these amino acids, which eventually leads to inhibition of DNA synthesis. ALS inhibitors include sulfonylureas, such as mesosulfuron, and sulams, such as pyroxalulam. In the case of ALS resistance, mutations in the herbicide binding site of acetolactate synthase alter its shape. As a result, the herbicide can no longer bind and inhibit its activity. This can result in complete loss of control. Acetyl coenzyme A carboxylase, or ACCase, is part of the first step of lipid synthesis. Thus, ACCase inhibitors affect cell membrane production in the meristems of grass plants. ACCase herbicides include three groups of chemistry: FOPs, such as phenoxaprop, DIMs, such as clethodim, and DENs, which includes only pinoxidine. Pinoxidine is a unique molecule with a unique mode of action. In the case of ACCase herbicide resistance, mutations in the herbicide binding site of ACCase again mean the herbicide can no longer bind and inhibit its activity. Different mutations can affect different products, or the whole group, depending on the shape of the chemical molecule and its ability to bind onto the target. Pinoxidine is a different shape to, for instance, phenoxaprop, and can therefore still bind onto the target when certain mutations, which affect FOP only, are present. Enhanced metabolism. Enhanced metabolic resistance results in degradation of the herbicide into non-toxic products for the weed. This is the most common resistance in grass weeds in the UK and affects most herbicides to some degree, but only in very severe cases does it result in complete loss of control. This is a summary of resistance types, which shows that pinoxidine is more likely to be effective against ALS and FOP target site resistant weeds.